Dear participants, welcome you all for the sixth day of the AICT sponsored ATAL online faculty development program on redefining innovation, AI and ML for Industry 5.0. We are very happy to have Engineer Vimalathithan for the session 11 and 12 today. Sir will be discussing on AI for ADAS and AI for autonomous cars for the day 6, 11, session 11 and session 12. Sir has completed his PhD, then done his PDF in Italy. Sir has specialization in AI and ML, IoT. More than he is a very good faculty, provides good pedagogical sort of training in electronics, embedded domain, IoT domain. He has own concern named Krishtec in Coimbatore, where he offers innovative solution in various thrust areas. We are very pleased to welcome you, sir, for this session. On behalf of GC Salem, welcome you for this session, sir. Thank you. Sir, now you have been made the co-host, so you can unmute, you can share the screen. Uh, 1 second, sir. Sir, now you have been made co-host, sir.
Very good afternoon.
Sir, good afternoon, sir. Welcome, sir. Welcome.
So actually, I connected in 3 systems.
Okay,
So,
yes.
can you make it all the 3 as proposed?
Sir, I mean, your Krishtec has been made co-host, sir. Vimal,
Yes, sir. Yes, sir. Vimal.
Both the Vimal, can I make it as co-host?
Yes, sir. Yes, sir.
Yes, sir, please. I will done. I have done it. Yes. Okay, sir.
Yes, thank you. Hope I'm audible.
Yes, sir. Yes, sir. Audible screen is shared. Yeah, fine, everything.
Yes, sir. Thank you. So I thank Professor Manibharati for this wonderful opportunity to address on this FDP. Thank you, Manibharati, sir, and the Government College of Engineering, Salem. Hope I'm audible. Yes.
Yes, sir. Audible,
yes,
sir.
Fine,
Audible.
fine, fine. Thank you. Just a minute. So this is a sixth day, and we are on the Saturday 2 o'clock, and the topic is A for ADAS. Any participants can say what is ADAS? Yes.
You can put the answer in the chat box, or else I will unmute. You raise the hand, I can.
Just to make it is interactive. Yes.
Any participants? What is ADAS? Advanced Driver Assistant. Yes, thank you. So what is the necessity for driver assistance system, and what is the necessity for advanced driver assistance system? Why we need it? And what is the necessity for intelligence for this ADAS? And of course, I'm going to talk about two topics. One is ADAS, and then connected cars. That is in case of autonomous cars, how this connectivity plays a very important role. Fine. So what is the necessity for ADAS? And maybe for the past 5 days, so you have learned about a lot of technologies, Industry 5.0, and then the topics related to AI and ML, right? Maybe near some industrial applications and university researchers. And what is the necessity for intelligence in case of this ADAS? Yes. To overcome human error. So why the human error occurs? Yes, of course, to overcome human error. And why that human error occurs? Anyone? Yes. So here, so I'm going to talk about the ADAS, V2V. V2V is nothing but a vehicle-to-vehicle communication, and then connected cars and autonomous cars, right? So V2V, what do you mean V2V? And of course, you would have come across this M2M. And now here, what is V2V? What is the necessity for V2V? Vehicle-to-vehicle. It is V2V communication. What is the necessity for V2V communication? Now, how this V2V takes place right now? Communication between vehicles. Right now, how the communication takes between the two vehicles? Any idea? Maybe Manimari sir, you can unmute for 2 to 3 minutes for the participants so that we can make it interactive, and then I'll go with the presentation. I think participants could not reply because it's unmuted. Maybe 2 minutes, you can make the participants unmute. Maybe 1 or 2 reply. Or you can raise up your hands in the chat box so we can unmute, and then we can make it this session interactive. Any participants? So here I have planned to show a demo, real-time demo. So we have planned for hands-on also, and then we have planned for the live demo by the in the car, the 2 models. Okay, so connected cars and then A in the connected class. So here, there are three types of communication: simplex, half duplex, and full duplex. And of course, everyone are experts so attending in this session. So there are totally 56 in the meeting, totally 56 other than that host and the co-host. You may be experts. So what is simplex and what is half duplex and what is full duplex? And yes. Now we can reply in the chat box. It is very difficult for you to unmute. One-way communication is which one, sir? Half duplex. And what about simplex? Thank you, Shuri Prakash, for your active participation and replying. So I am talking two-way communication at the same time, which is nothing but FD. Okay. So I am talking. So it's like a simplex, right? I don't know whether you are the recipients, right? And of course, I could see 56 participants, but I'm getting reply from 2 or 3, right? So Surya Prakash, okay, simplex having only one part or element. So let's take, I'm talking right now, and you are listening, and I believe that you are listening, right? And I don't consider whether you receive it or not. I'm continuously sending my message. That is, I'm talking, I'm taking the lecture continuously, right? So I don't have the feedback from the end users, that is receivers, that is simplex, okay? So the responsibility of the simplex is to broadcast, okay? And there is no compulsion that the listeners have to listen, right? So that depends on the message. So for example, if we take the radio program, okay, radio broadcasting, so there the radio signals are broadcasted, that is the message signal broadcast, right? So the radio jockey or the announcers does not know whether how many listeners are there and how many are actually listening and then reacting. But whereas in case of half duplex, so there may be possibility of getting the two-way communication, but one at a time, right? But if we take the full duplex, so two-way communication simultaneously. So right now, so I'm talking and I'm getting the messages from the few participants, right? So it's very important. It's very important. And of course, it is very difficult for this session to make it as full duplex because you are on the mute. Okay, so we can make it as half duplex right now, and then maybe at the end we can make it as full duplex, right? So this plays a very important role in the channel allocation, right? Channel allocation and the bandwidth. And if we take it half duplex and full duplex, so the allocation of channel number and the channel bandwidth, that plays a very important role, right? Because we have many number of devices connected at a time. So the challenging part is the channel allocation and effective utilization of the entire frequency band. Right? Okay. So here M to M. So what is M to M? It's nothing but a machine to machine communication, and H to M, right? H to M. So what is H to M? A human to machine communication. And here we have different, I have mentioned that different radio standards, BT, Wi-Fi, LoRa, and then radar and lidar. So we will talk about these radio standards and the radar and lidar. Okay, so in this advanced driving assistance system, right? Fine. So here, and of course, I have a lot to talk about the machine learning, right? So I will go to the directly for the machine learning, since we for the past 5 days you have heard about these fundamentals, right? So here on the screen you can see a machine. A machine. Can you name what is the purpose of that machine? And of course, location. I think it's very difficult for you to find out the location, but you can find out the application. Can you tell me what application this device is designed for? Yes, it is a robot. It is a robot. And, it's basically designed for traffic controlling. So it is equivalent to a traffic police. Traffic police, right? So what is the role of the traffic police? To control the traffic. So how we control the traffic? So based on the traffic density from the 4 sides, so you have to control the traffic. Of course, now we have the traffic system, that is automated traffic light system, right? Here, I like to put up one simple question, but let's take in traffic signal, okay, just a minute. No. Can you see my screen?
Sir, no, sir. No. You are sharing screen. We
Yes,
are able to see the
no,
Krishtec
no,
screen.
yes,
Yes,
yes.
now it's possible.
Now you can see your whiteboard, right?
Yes, yes, yes.
So you can reply in the chat box. Let's take, you can see the traffic signs. Okay, so let's take here we have the colors: red color, green color, and the blue color. Sorry, orange, red, green, and orange. Right. So when you see red color, what you have to do? We have to stop. When you see red color, we have to stop, and when you see green color, we have to stop. Right. But now consider the state. So from red to green, how the transition takes place, and from green to red, how the transition takes place. So in case of red to green, it will not, so it will go directly. Okay, so there will be some counter. So counter you can see from 60 seconds. Okay, so it goes up to, that is from the counter gets reduced from 59, 58 like that. So and then afterwards 5, 4, 3, 2, 1. Okay, so in this case, the red color goes to green color. But whereas in case of green to red, what about the intermediate state? Can anyone tell me? And of course, this question seems to be very simple, but plays a very important role in controlling the traffic. And that also very important in the autonomous cars. Okay. So red to green, and from green to red, what happens? Whether it will go from green to red immediately. I mean, what about the intermediate state? Any participants? So let's take, now the color is green. Now the color is green. Traffic light and the color is green. So let's take 30 seconds. So 30, 29. So it goes up to 6, 5, 4, 3, 2, 1. And then there will be change of state to red. Right? But here, whether the green color goes to red color directly, or whether you'll have any other color in the intermediate color. What is that color? And everyone knows that. I think the participants from all over India. So this question seems to be simple, but actually this is not the question. The next question, I will raise that actual question. So participants, please reply. What about the transition from green to red? Green, that yellow, that is orange, okay? So it will be cyan, orange, and then it will be red. And can you tell me at what time the green color changes to orange, and then from there it changes to red? Anyone? Yes, participants, please. And of course, we have seen this traffic light system in the main cities, and in all the traffic signals. Okay. At what time the green color changes to orange color? So in this transition, let's take from 30 seconds, 29 seconds, like that. Whether you got my question? Maybe 15 seconds. So actually, you mentioned 20 seconds, but if you see here, the total time for the traffic to clear is 30 seconds for one side. Okay, for one side. So let's take here. So now, okay, the traffic sign is open. So that let's check, this is A, B, C, D. Okay. So the traffic is moving from A to C and A to B and A to D. And let's consider there is no free left right now. Okay. So now, so here the green color has switched on. Okay, and the traffic is moving. Okay. So let's take 30 seconds is provided. 30 seconds is provided. So within the 30 seconds, all the vehicles have to cross the junction, right? And at a particular time, the vehicles have to stop. The vehicle have to observe the color of the traffic sign, and then they have to take the decision when to stop, right? So when they see that orange color, right, now the drivers have to take the decision to slow down, and then they have to stop, right? So I got two answers. So one is 15 seconds and another one is 20 seconds. On what basis that 15 seconds or 20 seconds is computed? That is very important. Okay, I put a question in another way. So any participants from Chennai and any participants from, let's take a small town like Erode or any metropolitan cities, right? So it's not based on traffic intensity. Now, as of right now, it is not fully automated. So in Gujarat, they have automated completely based on the traffic intensity. But in now, it is expanding to other metropolitan cities, right? So providing solution to this traffic signals is a challenging one, right? And most of the traffic sign, that is this company is working on this one, they try to reduce the stopping time, right? They reduce the stopping time. And of course, here, so I'm from Coimbatore. So in Coimbatore, 10 years back, they have designed a system so that you know, if you travel at a particular speed, okay, then you will not get stuck in the traffic. So you can clear all the signals through green color, right? But here, one more parameter we have to consider, the speed and the average speed. That is very important, the speed and the average speed. So for example, let's consider here, in this case, so at when the timer goes to 6 seconds, okay, there will be change of state from green to orange. Okay, so during this interval, it's 5 seconds. Okay, so the drivers, they have to take a decision, they have to slow down, and then they have to stop the vehicle. But of course, most of the drivers will rush up during this interval to cross the roads, right? But if we follow the traffic rules, so we have to take the decision to slow down. But in most of the cases, most of the roads, okay, they use the timer only 5 seconds. Have you observed this one? Say yes or no in the chat box. So we'll get only 5 seconds. We'll get only 5 seconds. Take the decision to slow down and then stop. So on what basis this 5 seconds is selected? But whether actually these 5 seconds will work perfectly, that is my question. Here we are talking about ADAS, Advanced Driver Assistance System, and of course the driver have to take the decision, okay, based on the traffic signal also. Yes. So I will put up this question at the last. Okay. So when the participants are unmuted, we'll come to discussion for this problem. But it is a very important problem. So this is the traffic police that was designed to work as a traffic police. This robot is defined for traffic police. So it was in Salem, designed 5 years back, right? Okay. So here we have to see the color of the traffic signal, and then we have to take the decision, right? But if you want to make it as autonomous, okay, so there we have to train the robot, that is a machine. So here the machine is in the form of human, so this acts as a traffic police. But here we are going to talk about the automotive electronics. So we are going to train the model in the form of four-wheeler or even two-wheeler, right? Okay, so I will put in another question. As participants, you can give the answer as option A or B. Try to pay red color. Option B. Okay. Okay, most of the answer is B. Can you justify your answer? Why not A? And of course, B is correct. And my question is whether A is not correct. Yes. Yes, based on color of the text. Yes. Thank you. I got the answer. Now let's wait for the answer. Any other answer from the participants? That is word green is in red color because of, yes, fine. And Professor Sendil, but you have given that and one answer. Yes. Word green is in red color. Fine. See here. So in this case, the question is not fully completed. So we have to raise another query here. So of course, A or B, but of course, I got the answer, mostly said that B, right? But Professor Sindhi, what you have mentioned that word red is in red and word green is in red color, right? Fine. So here, so we have to teach. Let's take how you teach the kid. So likewise, you have to teach the machine. Okay, the machine. So here, the color of the text. If we consider that, if we add one more feature with the question, the color of the text, then the answer is B. But if we take the meaning of the text, then the answer is A. Right. So of course, this question is not complete. In this case, identify the question is complete. Okay, so if get this question, we have to raise another question, that is, so what whether we have to consider whether the color of the text or meaning of the text. So likewise, so we have to add features, okay, for a particular parameter. So while training, okay, while training the model for a machine, so we have to add the features based on the experience, right? So let's take if you take that autonomous car while traveling on the roads, okay. So there you can see a lot of road signs, so that you will see. So how, based on the road signs, how this vehicle have to take the decision, right? So the same thing. See here, a robot that is used in the farming. Of course, this will identify the same color, red color. Okay, red color. Based on the red color, it will take some decision. So training the machine is same, but the reaction or the response from the machine, that depends on the application. Suppose if you are developing this application for an autonomous vehicle, so in this case, if it sees the red color on the road, then it's a traffic sign, then it have to stop, right? But whereas here in this machine, that is in agriculture, the machine is trained. So if it sees the red color tomato, then it have to click it, right? So the response will be different based on the application. Now, everyone is talking about Industry 4.0. Okay, so the IoT, that is the Internet of Things, it impacts more on the business. Okay, so adapting to this Industry 4.0 becomes mandatory in all the industries. Okay, and not only in automotive industries, even in academic. Okay, so there is called as Academia version 4.0, and even the small scale companies, they have to adapt to this 4.0 if they want to survive. So lack of knowledge about that 4.0 are the obstacles in adoption, right? So we will see why even the small scale industries have to adapt to this 4.0. Okay, this slide shows about the connected devices. All right? Just see the number of connected devices increasing year by year, right? Now I'll put a simple question. How many of you use a mobile phone with single SIM card? Okay. And how many of you use a mobile phone with dual SIM cards? Now we can reply the number in the text. So if you reply 1, then you are using 1 SIM card. If you reply 2, then you are using 2 SIM card, dual SIMs. Okay. 2 SIMs. 2. Anyone using 1 SIM card? Is there anyone with 0? No. 0 is not possible. 2. So how many of you use mobile phones with dual SIM cards, and 2 SIMs are active? Just to see here, 1 person using 2 SIM cards. So 2 connectivity is required for that single person. But not, other than that, mobile connectivity, we will have see a lot of connectivity is required for a single person, right? So here you can see an M2M SIM card. a machine-to-machine SIM card. Have anyone used this SIM card? Yes, please reply yes in the chat box. M2M SIM cards. So you may be using a 2G SIM or 3G SIM, LTE or VoLTE. In case of VoLTE, I think you may be using eSIMs. Okay. Have anyone used this M2M SIM card? Anyone? What is the difference between this M2M SIM and the SIM card that you are using? Say yes or no. So if you're not used, no. Say no. If you've used, yes. Say yes and where you have used. Yes. No reply. It's for metro station. What is the purpose of this SIM card in metro stations? I don't know. Maybe for all, what application you are mentioning? Yes. See here. We can use for security purpose to open the door. Now, in that case, we need authentication to open the door. But what is the purpose of this a machine-to-machine SIM? Any other answer? Participants? Yes. We will move to that how this SIM card that is used in the vehicles, right? Especially in vehicles, and how it will be used in connectivity for connected cars. Okay. Fine. So before going to that advanced driving system, we will talk about the smart city and how the smart city infrastructure that will be useful in this advanced driving assistance system. That is very important, right? So how you define smart city? Smart city. How you define smart city? So I'll put a question in a different way. This terms: smart classroom, smartphones, smart fridge, smart washing machine, right? So what is the difference between the smart classroom and a normal classroom, and smartphone and a normal phone, smart fridge and fridge? So likewise, how you differentiate the city and the smart city? So I expect at least 2 to 3 answers for this classroom and smart classroom. You can text in the chat box. So what does that word smart says? Okay. So I will have this as a question at the end of the session. We will discuss about this right later. so that we can go for discussion. That will be interesting. Advanced technology. What advanced technology? So I able to record a lecture, easy to teach with video PPT. What is the necessity for video and PPT? Okay, thank you. Thanks for reply. We will discuss about this one. That is the classroom. Okay, easy to learn. Yes. Actually, if you take a classroom, the main purpose of the classroom is to transfer the knowledge from the teacher to the students, right? So a good teacher can use a blackboard, chalk, and then he can teach and then make the students to understand. But using the latest technology, advanced technology you mentioned, right? So you can teach with videos or PPTs so that the students can easily understand, right? But the main objective is to transfer of knowledge. So we use latest technology devices to transfer the knowledge. Okay, so that the students can easily understand. But the main purpose is to transfer knowledge. So we use the latest devices or technologies. Likewise, if you take the smart city, okay, the people's requirement have to be satisfied. Okay, so the fundamental requirements, let's take the basic infrastructure like roads, hospitals, and then malls. So fundamental requirements, so that have to be satisfied. Okay, so once if that requirement is completed, then the people need may increase. So for example, if we consider here, so among this the different phones, which one is smartphone? The first one, enabling various key technologies. Okay, so here you can on the screen you can see the different phones, right? So which one is? Let's take the first one, the older model. Okay, using your fingers you can rotate that dial for dialing. The second one is cordless, and the third one is mobile, and fourth one is also mobile. Okay, and the fifth one is also mobile without any physical device. So among these, which one is smartphone? Let's take 1, 2, 3, 4 in the first row and the 5 in the second row. You can reply in the chat box. So which one is smartphone? As I already said, 4 is smartphone. Okay. As I already said, the fundamental requirement that have to be satisfied. So if you take the city and the smart city, right? Or you take the classroom and the smart classroom, the main requirement in case of classroom is transfer of knowledge. Okay. So for example, if you consider the requirement is to communicate signals through voice. In that case, the first one is also a smartphone, right? The first one, that is the old model. What is the main requirement there? So just you want to communicate, right? So this is your requirement. So your requirement is satisfied. So now this phone is called as a smartphone. Let's take the second case. So wireless phone, okay, that is cordless phone. So in the first case, if you want to make a call or receive a call, then you have to go to the place where the phone is and then you have to use the device. But whereas in the second case, so you can use the phone within your home. See here, now if you have added one more parameter in your requirements, so I want to talk or I want to communicate, but I have to roam within my home. So in this case, the first phone is not a smartphone because your requirement have increased because you added your requirements. So likewise, if you take the third one, so you want to communicate, but we want to move within the city. So in this case, the second phone is not a smartphone. Likewise, if you take that fourth one, so you have mentioned the fourth one. See here, in this device, you can do a lot of things. You can go for internet browsing, or you can use apps for internet banking, right? So if you don't want these features, then you can say the third one is a smartphone. See here, the word smart, so that is not unique. Okay, so that depends on the time and age. So the requirement have to be satisfied. That is the main thing for smart, right? So now here we have the smart cabs. What is the difference between cab and smart cabs? So using the apps, okay. So we can the cabs, and I will talk about the data, how the data is utilized and shared in this cab application and then food delivery application, right? And then we'll come to that the driver assistance system. See here, this is the two-wheeler cab. Okay, two-wheeler cab, that is over cycles and then two-wheelers, right? So here, this slides about the complete cab, that is four-wheeler cab or two-wheeler cabs, right? So let's take, if you want to book a cab, so what you will do, the users, the end users, so they will share their location and then they will request for the cab service, Ola or Uber, right? The same way, the service providers, right? The service providers. Here, what happens? They will share their location, and then they will say that, so I am providing service in this, and I'm in this location. So this application will connect the users and the service providers, right? Let's take another case, food delivery application. Okay. So here, so if you want to order a food, so what you will do? So I'm in this location. I need these food items, right? In the same way, here service providers, let's say the hotels. So they will share the datas. Okay, so this is the hotel, and here these are the menus available. So you can select the food items based on your requirements. If we consider this food delivery app and the cab booking app, okay, the technology behind these two applications is same, but the application is different. That there you are booking a cab, whereas here you are booking a food, right? Now, see here, the collection of data, okay, the collection of data. So how it can be effectively utilized to increase the business, right? So let's take a Google weather forecast, okay. So now we consider this cab service. Okay, whether this cab service depends on the Google forecast, weather forecast. Is there any relation between the Google weather forecasting and then the cab service providers? Any answer? Fine. See here. Okay. So here on the slide, you can see the McDonald's. So how they increase the sales based on the weather. And of course, you may be wondering. So the topic is advanced driver assistance system and then AI for ADAS and connected cars. How it is related, this McDonald's sales is connected to this connected cars. Do you have any doubt on this? Yes, I'm talking about that weather forecasting and the sales and then coffee, right? Yes, whatever we are discussing, so that, and finally, at the time of conclusion, we will see how all these are related, right? Fine. See here, in the summer, if it is hot summer, right? So what you like to have? You like to have cold items. But whereas in the case of rainy weather, so you like to have hot coffee, right? So based on the weather, see here, the sales of the McDonald's, not only McDonald's, any hotels, right? Or coffee shops, and how this weather affects this transportation business also. See here, so let's take the weather is hot, sunny. Okay. So in this case, the shopkeepers, okay, or coffee shops, they can prepare cold coffee or cold drinks or ice creams. In case of transportation, so you can prefer a car or open type car, or you can prefer two-wheeler or cycles. And even you can go by walk. Okay, that depends on the budget. So you can select based on the your requirements, right? But if it is rainy, right? So in this case, the shop that is the food stalls or coffee shops, they will prepare hot coffee or tea, hot snacks. And the service providers, if you come to the transportation, okay, the service providers, that is two-wheeler cabs or cycles and open jeeps, they can stop their services because it's going to be raining. Okay, now they can increase the number of cars. Okay, so people will not prefer this the two-wheelers, right? And even if you want to go by walk, you can use umbrella, right? See here, this data, how the connectivity of this data for snack shops and the transportation, right? So at the end, we will see in infotainment. Have you heard about infotainment? What is infotainment in the car dashboard? Anyone can reply in the chat box. Infotainment. Yes. Participants, are we really connected? Nearly 87 participants are here, right? Okay, I have a demo. Also, I'll make it fast. Fine. So here, so this was about the evolution. Just a minute. Okay, this shows about the evolution of industries from 1 to 4. All right. So if you take that industry 1.0, so they use mechanical systems for productions. And if you take industry 2.0, they use electricity for mass production. And if you take 3.0, so they have automated the production using the information technology and electronics. But in case of 4.0, they have integrated digital and physical system, IoT, and data analytics and robotics, right? Just to see the evolution of industries from 1, 2, 3, 4. So here we are going to see about the evolution of cars from various generations, right? So level 0, no automation. Level 1, driver assistance, right? Level 2, partial automation. And then 3, conditional automation. So for example, if you take the level 3, the driver have to be aware in case of emergency or backup systems. So in case of level 4, the driver will be there, but he can take rest, right? He can take rest. Completely, the system will be automated. So in case of 5, there is no driver, right? So we will talk about how these evaluation and what about the technologies and how AI will be incorporated in this level 3 and 4. So of course, AI plays a very important role in 5, but I'm going to talk about 3 and 4 only. Okay. Now we can see the different cars. And of course, you know that cost of these models. So which one is, let's take the first one, white color. Of course, it is not in the market right now, but you know the price. And what about the price of the second one, third one, and fourth one? Why the cost differs? What is the reason for having huge cost? Anyone? Yes. This will be very interesting. Okay, let's take if you are buying a new car, what are the features you will consider? And let's take you have this operation brand. Okay, brand, luxury. Any other answer? It's 14 lakhs, 50 lakh, 1 crore. See, there are 4 cars, but you have mentioned 1 crore. 1 crore, which car, madam? Last. No, it will not be 1 crore. It's safety features. It's exactly safety features. So the last one will not be 1 crore. It will be more than that. I will tell you why. Right. So why the cost differs? Why the cost differs? As I said, the smart classroom and classroom, right? So what is the difference? So likewise, if you take a car, what is the purpose of the car? Okay, speed, mileage, that are parameter is fine. What is the purpose of a car? What is the purpose of a car? Not comfort. It's a 4-wheeler. That's all. What is the purpose of the vehicle? Any answer? Transportation. Yes, exactly. Travel, transportation. That is, we use car to move from one place to another place, right? So here, that is the main requirement. Main requirement is transportation. And of course, here we have 4 different varieties. If we consider that first one, and of course, in older days, we feel that that was comfortable one and luxury car. But as time changes, okay, and the technology evolves, okay, and you can see that if you say see that second car, third car, fourth car, in all the cars you will have comfortness in all the cars, right? But if you consider these features, okay, that is comfortness features, and then there is luxury features and the safety features, okay. So if you consider the fourth model, so the safety features is high, that is more safety features, and then more comfortness, right? So we will see what are the safety features. So while buying a new car, so we can consider these things, okay, price, mileage, and safety parameters, okay. So if you consider safety parameters, airbag, child lock, 360-degree camera, speed limiter. What is the purpose of airbag? What is the purpose of airbag? Yes, what is the purpose of airbag? So let's take, while buying a car, so you are considering the features. Let's take airbag, and then you are considering an infotainment, an audio system. Safe life, protect. Okay, fine. So let's take, I'll put a question in a different way. One person is buying a new car, okay, and then he's enjoying the audio system. He was very happy because the audio system works perfectly, and then the clarity of sound, music, effects were perfect, and he was very happy. And the audio system works perfectly. Now let's consider another system, airbag system. He's driving fast, okay. The person is driving fast, and when he hits an obstacle, and then the airbag system worked perfectly, and then airbag released, and he is safe. Whether he will be happy? Yes or no? You can reply in the chat box. That is, you consider that entertainment case, the system, audio system worked perfectly, right? In the same way, if you consider that the safety system, airbag, it also worked perfectly, okay? Now, whether the user will be happy or not, because both the systems work perfectly. See here, it is very important. You know this guy? You know this person? He's a renowned scientist. So he is Leonardo. Okay. So he was one of the manufacturer of car in India. Okay. So he built his own car. So see here. Basically, I said that car is for transportation. The car is for transportation, right? So this is the bus he built. You can see that the various evolution of cars. Okay, and then this one shows about that MG, the firstborn MG, and right now in 2020, so MG Gloucester. MG Gloucester is autonomous vehicle. Now MG have introduced MG Astra A inside. Okay, so we will see about this vehicle, that is this car, and the car with the safety features. Fine. Now, let's consider the smart car. Okay. So, what is the purpose of this buttons in the car? Mobile, that is attending mobile, that is through Bluetooth. But what is the traffic rule says? While driving, if you use mobile, you will be charged fine. All right. You should not use mobile while driving. But nowadays, the car comes with that connecting through Bluetooth to mobile, right? So whether it is a comfort feature or safety feature. Yes, please reply in the chat box. Whether it is a comfort feature or safety feature. Comfort, yes sir, comfort. But why not safety? But it is not safety. Yes, we have to consider safety features. I'll put a question in a different way. Let's say you are driving the car. Okay, you are driving the car. Let's say you are seeing the red signal on the traffic. You are stopping your car. Immediately, what you will do? It's a normal human mentality. Immediately, what you will do? You can type in the chat box. You are driving the car on the road and you are seeing the red signal on the traffic sign, and then you are stopping the car. And after stopping the car, what you will do? Normally, people will take their mobile and see the social networking message. Do you agree with this? Right? Do you agree with this? Everyone, right? Even, yes, watch mobile. Fine. Yes, that's a human mentality right now, right? Even there is no messages in the WhatsApp or social networking or mail, we will take and watch it, right? See here. Fine. We'll talk about this one, the safety and comfortness. So let's take the indicator. Okay. So while stopping, normally we have to indicate to the other drivers. So what is the purpose of right indicator and left indicator? And what is the purpose of both indicators get switched on? All right. Anyone? What is the purpose of right indicator and left indicator? And what is the purpose of both indicators switched on simultaneously? What does it say? Of course, these are the traffic signs. So here, a driver is communicating with another driver. And I already said about a vehicle, we have to talk with another vehicle. So we'll come to this one. So these are the traffic signs. Okay. So we can see the broken yellow line and continuous yellow line and the continuous parallel lines and single yellow lines and the different colors. So we will talk about this in advanced driving assistance system. Okay, but you must know about the meaning of these traffic signs. Okay, so let's take here in this highway. So here, if you take the right indicator, it have different meaning. So it says that you're going to turn right. But whereas here, the same right indicator or left indicator gives the different information. So we are going to change the lane, right? So here you are communicating with the other drivers, okay, in a smarter way. Okay. But whereas in case of V2B, these information have to be exchanged with the nearby vehicles, right? Okay. So let's take this vehicle. So if we consider that the advertisements, so this is the India's first internet connected car. Okay, this is first India's internet connected car. So how internet? As I already said that the M2M SIM. Okay, so this device, I'm calling this vehicle as a device. Okay, so this comes with an M2M SIM, an M2M SIM. So likewise, if we consider another device, so this is a watch, okay, that is used to monitor the health condition, okay, of a human. So this also comes with the SIM, M2M SIM. So here we use eSIM, okay. So M2M SIM is different from this normal SIM, of course eSIM. So M2M is only for IoT applications, only for IoT applications. Okay. So now we're entering into the topic advanced driving assistance system and why this is required and V2V. So till now we have discussed about the traffic rules, the traffic signs, and then identifying colors. Okay, and then we discussed about the weather. So based on weathers, so how the food shops or the transportation we prefer. So of course, it seems to be the different from the topic related to this ADAS, but finally put together. Okay, so an infotainment. So it will all converge to this infotainment. So that is one module in this advanced driver assistance system. Okay, so here we consider this slide. What about the risk of this kit? And that cone that says about the visible region for the driver, right? So this was the visible region for the driver. Now, what about the risk of life for the kid? And mostly, this is a challenging issue. In most of the schools, the driver could not see the kids playing around the buses. 2 years back, so our Indian government have made it mandatory to install the ADAS cameras in all the school buses, right? Fine. We consider this case. We consider this slide. Okay. While driving, if you sneeze, what about your eye? Your eye will be closed for 1 second or even less than a second. But you are driving the car at a higher speed. Now, what about the visibility of road for the driver? In the second case, you refer to the second case. A mom and kid is crossing the road, but the driver is watching the mobile. As I already said, if you are using the mobile while driving, okay, and you are talking, so it is safer than watching social networking on the mobile, because your eye will be concentrated on roads while speaking. But whereas in case of while you see the social networking on mobiles, or if you see the mobile, okay, your eye will be concentrating on the mobile, not on the roads. Consider the second case. And consider the third case, a kid is playing near the tire, right? So normally, okay, what about the safety or what about the risk factor in all the three cases? And I also said about why this car is costly, this one. The fourth one. Maybe you see that the top of the car. So it comes with complete 360-degree 200-meter view. We'll talk about that one. Yes. A good driver will make all the three conditions safe. Okay. So while sneezing, if the good driver sneezes, he knows how to control the vehicle. The same way, if we see the person crossing on the road, right? So he knows how to control that vehicle smoothly. He will not apply sudden brake. He will not apply a sudden brake. Okay, a good driver. I'm talking about a good driver. But a normal driver, so he because of seeing the object on the streets, he may get scared and then he try to apply sudden brake and then slow down the vehicle, right? Whereas in the third case, the kid is playing. So normally a good driver will have to check. He will check the vehicle that is under the vehicle whether any pets are flying. So uh, he will make all the conditions safe. All right. So when I was in University of Bologna in 2010, so this is the autonomous vehicle designed at that university, but they used only the camera perception. Okay, so they used only that video processing, camera perception. But now with the technology, lidar and radar. Okay, lidar and radar. So here you can see the sensors. Okay, in front and the top, right? So we'll see how these sensors will be useful in controlling the vehicle, controlling the speed of the vehicle, right? So here, lidar, so light detection and ranging. So here, how we have bat place, So it generates ultrasonic sound. Okay, when there is an obstacle, okay, when the sound gets separated back, so bat computes the distance and based on the distance, so it will turn away and then it flies. So in the same way here we have the source, light source, right? So the source will emit light, and when it incident over an obstacle, the light gets reflected back. Okay. So the round trip time taken by the light. So we know the speed of the light, and then the distance between the source and the obstacle can be computed based on the round trip time. So this is the principle that is used in lidar to find out the obstacle, right? And of course, here we have to consider actually the media, that is the medium. So here we are considering the air as the medium, right? But this will not work in snow regions, okay, and in cold countries. And then suppose if the vehicle goes in the roads during rainy period, so there will be a huge risk. So there will be the delay in the reflected signals, and then it may show a wrong value. As of right now, they have considered the normal conditions, okay, and then they have considered the special cases also. So we will talk about that the absorption losses. Maybe it's very difficult to discuss about the absorption losses in between the source and the obstacle, right? So here, this is also about that lidar. Okay. So this is a fundamental principle. So the transmit pulse and the receive echo, and then the time. And please make a note, the vehicle, and here we are talking about the source is stationary. Okay, but whereas in real time, the vehicle, so this vehicle, let's take this vehicle will be moving at 200 kilometers per hour. Okay, when the obstacle comes, so it have to compute the round trip time, and then it have to compute the distance between this vehicle and the obstacle, right? And it have to take the decision immediately, and then it have to slow down the vehicle. Just think of a normal human driver by seeing using a normal human eye, and then he is responding. Okay, but the complete automation system, it have to respond less than a second, right? So let's take an open loop system. Okay, so here the system takes the input and then it processes it in the output, right? So let's say if the driver is seeing the obstacle, so he is not responding. That is, he is not responding. So he is seeing the output, but he is not giving the feedback to apply brake. Now what happens? The vehicle hits the obstacle. But whereas if we consider the closed loop system, if there is any obstacle, okay, the driver will decide when to apply the brake. So that depends on the distance between the vehicle and the obstacle, right? Suppose if the obstacle is stationary, then you have to slow down the vehicle and then stop it. And if the obstacle is moving, okay, and if it crosses the junction, just he will see that there is an obstacle. Based on the distance, he will take decision whether we have to slow down or we have to apply brake and stop. Okay, we will see the different cases. See here, this shows the complete the parts, that is architecture. So here you can see that the sensors, the light sensors, and then based on the time of flight measurements, okay, it is processed using the digital processor, okay, and the decision that have to be taken based on the distance, and it controls the motor driver, and slow down the speed of the vehicle. Right. See here. So here, this comes with the different sensors. Okay, front radar, side radars, LiDAR sensors, electronic control unit, front camera unit, surround view cameras, corner sensors, and steering angle sensor. I'll talk about the steering angle sensor. It's very important, right? So, for example, you are using a power steering angle. Let's take you are rotating the steering to completely right, and then if you leave your hand, what will happen? In the same way, if you take the steering angle, you are completely rotating to left, and then you remove your hands. Now, what will happen to the steering? Anyone? Yes. What about the steering position right now? Return to original. What about that original position? Yes, answer is correct. What about the original position? What about the wheel position? Straight. Fine. So see here, whether you rotate completely to the left or half of the left or completely to the right or half right or 20% to the right. So whatever may the position, so if you leave your hand, it will automatically rotate and comes to the straight position. All right. So likewise, you take the front radar sensor. So here, this is for adaptive cruise control, emergency braking assistant, stop and go function. If you take the LiDAR sensor, so that is for ACC and lane assistant. See the difference between LiDAR and radar. It's very important. Okay, LiDAR. So here it is used for lane assistant. It can differentiate colors. And if you take the camera, so camera is also for lane assistant, speed limit display. Okay, and then if you take that surround view camera, so it is for 360-degree view. All right. See here. Here, there are two types of processing: centralized processing and distributed processing. So just see sense, input, process, and output, act. Okay, so if you consider this one, so this is the basic block. Okay, the input, system, and output. The system will process the input and also based on the feedback from the output. So it's the same one here. Sense, input, that is here we have the sensors, camera plus sensor, radar plus sensors, and LiDAR plus sensor. And understand, that is the system. Okay, that is sensor fusion, and act, output. See here, that depends on the distance between the obstacle and the vehicle. All right. So if the distance between the obstacle and the vehicle is far, so do nothing. If it is in the danger zone, okay, give warn. If the driver does not apply brake, then take assistance. Even if the driver fails to apply brake, control the vehicle by applying brake or steering, that is turn. Okay. See here, see that action, that is output. So that depends on the distance between the obstacle and the vehicle. Do nothing or give warning or give assistance and take control. Right. So for example, if you are moving at a higher speed, okay, if you're moving at a higher speed, if there is any obstacle comes in front, okay, it will give the warning, okay, an indication. You will see what this one in real time, right? See here, this is the car that is shown in the fourth image of the four different models, right? So you can see that the inbuilt sensors. So this device can view 200 meters, 360 degree, 200 meters. Right? Even at the movement, okay? That is higher speed, that is traveling. Now you see the risk of life. Okay. So this will be very interesting, the state and transition, okay? Adaptive cruise control, standby, that is on. If the adaptive cruise control is on, now what happens? Once if we activate that adaptive cruise control, now what happens? So I think now time is 3:25. Maybe I will wind up with after completing this topic, state and transition, and then we will have a break, and then we will proceed further with the demos. See here, let's take the two vehicles are moving at a constant speed. Let's take 100 km per hour. Let's take target vehicle and then ACC vehicle. ACC vehicle is the adaptive cruise control vehicle. So how many of you used adaptive cruise control while driving? Please reply yes in the chat box. How many of you used adaptive cruise control while driving? Say yes in the chat box. Manibharti sir?
Sir, yes.
That maybe we can unmute the participants for next 4 minutes before taking the break. We will have a small discussion.
Yes,
and then we'll wind up for break.
Yes, sir. Yeah. Allow participants to unmute themselves. Yes, sir. I have made allowed them to unmute themselves.
Thank you, sir.
Yes, sir.
Okay, how many of you used ACC while driving? See here, when the two vehicles, okay, are moving at the same speed, the target vehicle and the ACC vehicle are, what about the time gap? The clearance between the ACC vehicle and target vehicle, it will be same. Suppose if the target vehicle increases the speed, now what about the time gap? The time gap will be increased. So now take another case. The ACC vehicle is moving at 100 km per hour, and the target vehicle is moving at 100 km per hour. Now, the ACC vehicle have increased the speed to 120 km per hour. Now, what of the time gap? Time gap gets reduced. That is, the clearance gets reduced. In another case, the target vehicle and ACC is moving at 100 km per hour. Now, the target vehicle have applied the brake, and now what happens to the clearance? The clearance will be reduced. So what about that ACC vehicle have to do? Since the gap is reduced, so based on the distance between the two vehicles, the ACC vehicle have to take decision whether it have to slow down or stop, right? So that is nothing but this one. See here, do nothing. If both are traveling the same speed, do nothing. If the target vehicle is reducing speed, give warning. So now the ACC vehicle have to reduce the speed. But as of right now, ACC will not reduce the speed. The driver have to apply the brake and then it have to reduce the speed, right?
I'll use this game as an example of how to attack with rogues.
So these are different cases. And please make a note, the vehicles are traveling at 100 km per hour. The radar or lidar sending the signals, and when it inserted over that obstacle and it reflected back, and it have to compute the distance, and then it have to compute the decision whether what you have to do. So it should be done at a quicker time. That is very important, right? So that is taken by the processor, and of course here two types of processing: centralized processing and distributed processing. In case of centralized processing, all the data will be sent to the main processor, and there it will be processed and then take decision. Whereas in case of distributed processing, the processing and the decision will be taken at the different nodes itself, right? But in both the cases, it have to sense, understand, and act. Fine. So I will take a break. Maybe we'll have a Q&A session right now for 2 minutes. If not, we will have the break and then come back after the break. So at what time we can come, sir?
Sir, maybe after 15 minutes, sir.
Okay, sir, fine.
Yeah, 3:45.
We can start by 3:45. In the meantime, if you have any queries, we'll have a discussion. Else, we'll wind up our break.
Okay, sir. Thank you, sir.
Host reactor
Okay. Session starts at 3. Erase for erase for 3 p.m.
Manibhardi sir.
Sir, yes.
Actually, there will be one
Yes.
more participant, Karthikeyan. அவர் கொஞ்சம் ரைட்ஸ் கொடுங்க சார்.
1 minute, sir. 1 minute, sir.
கார்த்தி டெக்ஸ்ட் பண்ணுங்க.
பண்ணிடுறேன், கொடுத்துறேன் சார். சார் குட் ஈவினிங் சார். குட் ஈவினிங் சார்.
கார்த்திக். Karthi, share your screen. Let's check it and then.
Sir, Karthikeyan sir, co-host about this, sir.
Okay, sir. Thank you. Okay. So here we discuss about the state and transition, right, in ACC. So here we are going to show the demo. Karthi, once if it is ready, text me in the chat box. We'll go to demo. So here, DAS, driver assistance system. So we call it as RAS, rider assistance system for two-wheelers. Okay. So the survey says that the motor accident could be reduced. We use that the ADAS. Most of the accidents could be avoided. So here you can see the two sensors, front radar sensor and rear radar sensor, right? So here we can see the two-wheeler is on the road. So this two-wheeler is enabled with ACC, adaptive cruise control, right? And a vehicle is moving in front. Let's take the car. The car driver have applied the brake. Okay. Now, when the brake light gets switched on, the rider, the two-wheeler rider, after seeing the brake light, we have to slow down the vehicle, or you have to take the decision. Okay. Suppose if he doesn't take the decision, he does not apply the brake, so automatically this ACC will take decision, right? And then the control will be taken, and then it will be slowed down. So the next one is blind spot detection. Blind spot detection. So here you can see the rear view mirror, okay, and then the visibility region. So that is shown in the blue color, right? So there is a vehicle, a car coming behind the bike, but that is not in the visible region. That is in the blind spot region. So it is not shown in the mirror. Nowadays, you can see that the blind spot detection that is in the side mirrors, right? So 4 years back, only Benz had that feature, but right now the Hyundai and other latest cars, so that comes with that the blind spot detection, so that enables a light in the side mirrors. I think most of you have noticed this one, a small red color light triangle, so that will be displayed on the side mirror. Now we can see that when the vehicle enters into the visible region, okay, right, now we can see that the indication. So this is a blind spot detection. So forward collision warning. Okay, so now here the vehicles in the front going, that is, you can see the lot of vehicles going in the front direction. Now, if any one of the vehicle that is in the front side vehicle, okay, So see here, one vehicle have tried to brake. So after seeing that the brake signal, all other vehicles have slowed down, right? So this shows about the specification of ADAS, and then multi-purpose camera. Okay, so this is another one, that is camera. So if you see that radar or lidar, so radio signal or light signal that will be used for the detection of obstacles. But whereas in this case of stereo camera, so it sees like a human eye, right? Yes, Karthi, are you ready?
Yes, sir, I'm ready. Can you hear me?
Yes,
Yes,
yeah.
Karthi, I can hear you. Now
Okay.
we'll show you a small demo about the connected vehicles, right? And then the features what you have seen here. Okay, Karthi, you turn on your camera. So you share your screen. First, you turn on your camera. So actually, he is in the vehicle. Actually, we have integrated two parameters, AA and OBD, onboard diagnostics. So here you can see that an onboard diagnostics tool that is connected on the OBD port. I think the participants can, Kathy, you are not on the main screen. You share your screen.
One second.
Okay, now fine. Now,
Is it fine, sir?
yes, fine. Okay, so this is the OBD port. Now you show that roads, and then show me that the app, and then share that app screen.
Yeah, one second.
Actually, here we have taken the important parameters so that the participant can easily understand what are the parameters. So, for example, if you take the dashboard in the car, you can see the engine RPM, the vehicle speed, the fuel level, and then brake lights, and then few status of the engine conditions, right? So that can be easily understandable by the participants. But if you take the OBD parameters, nearly 700 parameters will be there. You can take these 730 parameters and then you can monitor the health of the car. So for example, if you take the Apple Watch, right? So what is the purpose of that watch? So that monitors the human health condition. So let's take the body temperature, and then pulse rate, and then footsteps, and other medical parameters. ECG also. Nowadays, the Apple Watch comes with monitoring ECG, right? Basically, it is for monitoring the health of the human. So likewise, so you can monitor the health of the car. So by analyzing the 700 parameters. Yes, Karthik?
Yes, sir. Actually, I couldn't able to share my mobile screen.
I think start. Manipal, sir, can you make him as a co-host?
Sir, he is already co-host only, sir.
Yeah, I am already co-host actually, but I couldn't able to share my mobile screen. I
What
can
it is
able to
coming,
share
sir?
my
While
camera.
you try. Okay. 1 second. Thinks your camera is turned off actually. Yes, now it's on. Yes, fine.
The camera is fine,
Share
but sharing the screen,
it. Can you able to see my screen?
no,
No.
it's not yet shared. Okay, Karthi, I think you have to enable the sharing the screen in the settings of your mobile. Okay. Your mobile camera is on, but you have to switch off the camera and then you have to enable screen sharing in Zoom.
I turned off my camera. I'm clicking on my screen share.
So what you can see?
Display over other apps.
Yes.
Seeing display over other apps.
Yes.
Okay, sir. Now I can share. Can you see my screen?
Yes, yes.
Okay.
I think it will be slow.
So this. So can you able
Yes,
to
yes.
see my screen? Yeah. So I'm logging in. Okay, it's logged in. So few of the details are there. My driver score and my car company and my car number and OBD. OBD2, I'm going to use OBD2. Then you can see the MAC address of that Bluetooth device also. So I'm going to give stack. Yes, tell me.
Okay, so please note on the score, it's 74 here. We'll talk about 74. It's very important. So what does it say? Okay, Karthi, proceed.
Okay. So I'm now starting. So before that, what we have to do is we have to connect with the Bluetooth. So let me go to my Bluetooth setting. Okay. Here is OBD2. I'm going to forget it. Okay. 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 Forgot. Then I'm going to connect it again. So can you see? OBD is showing. So I have to click it and I have to connect with it. I'm putting the password. Okay. Now in the backend, I connected with the Bluetooth. So what I have to do, go to setting and I have to connect with the app. So now it's connected. Okay. I have to now it's connected. Can you see my RPM over here? It's showing in the.
Actually, now the vehicle is at rest. The vehicle is not moving. So you have started the vehicle. Now just is pressing the accelerator. That's all. Pressing the accelerator. Pressing the accelerator so that you can increase the RPM.
Can you see the change in the RPM?
Yes.
So I'm
It's
going
actually,
to move the vehicle.
okay, slowly move it.
Can you see the change in speed?
Kathy, apply
Can
sudden
you able
brake.
to change?
Apply sudden brake. You can see that message sudden speed increase detected. Then you apply sudden brake. Now we go to the score.
Okay. Just a minute, sir.
Okay.
Traffic. Can you able to see, sir?
Actually, OBD failed. Yes.
Nobody failed. Okay. Once again, I have to reconnect it again. So it's a little bit loose. That
Okay, Karthi. If try once,
yes, sir.
and if it's failed, then open that street view.
Okay, sure. Just now it's connected.
Now we can see that this the distance covered, that is initially it was 0.1, later is 0.2, and now it's 0.3.
Okay, sir. I'm going to move my vehicle. I'm going to apply sudden brake.
Okay, if sudden brake is applied, just to see the speed, it comes to 3 km/h. Okay. Okay, now we go to the driver score. You complete the driver
Okay, sir. Okay, sir. I'm going to. Sir, there is my driver score 84.
participants. Do you remember the previous driver score? Any participants?
Around 70 something, sir.
Actually, this question is for participants.
Okay.
Maybe you can go with the day mode. Okay. Here
Okay, sure.
we have
Sure.
seen about the RPM and the speed of the vehicle, and then how the brake is applied. Okay. So we have computed the driver score. So we will talk about the driver score after that demo. Okay. Proceed, Karthi.
Okay, sir. I turn on the camera and AI detection.
Actually, the settings, you close the settings. Okay. You can see that the road view, live road view. So you can see that
I'm going
show
to move my
enabled.
vehicle.
Okay.
So I'm going to move my vehicle.
Actually, here there is no road signs. If we could find any road signs. Okay, so here you can see the person detected and the distance. And of course, there is no traffic signs here. So this seems to be side roads. If there is a traffic signs, then automatically detected and then it will show here. The speed limit, a turn right, turn left, or whatever the sign.
A person just crossed, so it's detected the person. Let me go to main roads.
Okay, please be careful.
Yeah, sure. Can you able to see, sir? It's
Yes,
detecting
yes.
the cars
Yes,
and
yes.
the vehicles.
Actually, he is driving at nearly 40 km per hour. But okay, slow down. You can see that traffic signs. Okay, we have to enable the traffic signs. Okay. Actually, here this one just gives the warning. Okay, does not give the assist or control the vehicle, right? And also here we have to add, that is enable that traffic sign model. Okay, so here you can see the different traffic signs. I think maybe you can come to side roads. You apply brake multiple times and then come to side road. You slow down, you accelerate.
Once again, sir, OB is not connected.
Okay, no problem. Okay. Okay, Kathy, that's fine. Or maybe you can slow down.
Okay.
You can stop. Right.
Yeah.
Actually, this is the model. Actually, we have developed for 1 credit and 3 credit courses, especially for students. So how actually ADAS system works, and then how to compute these parameters. So we have framed as a 3-credit course, especially for learning. Fine. Thank you, Karthi. Now we go to the scope. Okay. So now I will go with the same application in a different model. Okay, MG. Fine, Karthi, thank you. Any queries, any doubts, participants? You can stop sharing your screen, Karthi.
Sir, it's really wonderful to see this. Really, sir.
Thank you,
How
sir.
I mean, sir? How, sir? This is in credit. How in credit system you are bringing into it? Students, what they will learn from it or develop.
Actually, we have framed that courses, sir.
Okay.
Connected class course. So
What
there will
course,
be
sir? Connected
class.
Okay, okay, sir.
So they will develop the application.
Which
So they will
department,
learn
sir? Is it an elective paper or?
So that depends on the autonomous institute.
Autonomous institution. Okay.
We have created 3 credits for autonomous institutes and 1 credit for autonomous institutes.
Oh.
So they will develop. So I will show that actual app right now.
Okay, sir. Yeah. Since most, all our faculties, they can take away from it from you.
See here, this is the app for internet connected car. Okay, the hectare. So here you can see the menus, remote control and smart drive. So if you take remote control, it is nothing but an IoT car. If you take a smart drive, it gives the data analytics. For example, if you take that remote control, you can see here central lock, air conditioner, sunroof, tailgate. So you can control these things. That is, you can open the car, or you can switch on the air conditioner, or you can open the sunroof from any part of the world, right? So, for example, if I switch on this, then the car engine gets switched on, and then it will be switched on for 10 minutes. So now the door will be unlocked. Okay. So if you switch on the AC, okay, now we can see that the location of the vehicle. So where the vehicle's location. Okay, so it is in Coimbatore. Okay. So the vehicle is here. So this gives about the IoT applications, right? And here, this gives about the fuel tank level and then fuel range. So 340 kilometers, I will explain about how this is computed. Okay, so based on the available fuel, and based on the driver's score, this range will be different, right? And you can see the data, totally 39,000 kilometers. That is the car have traveled. Okay, and then based on the current fuel, so the distance covered will be 340 kilometers. And also it depends on the driver score. So how it is like driver score. See here. So here I already said about if you take the smart drive, it is about data analytics, right? So you can see the parameters, fuel efficiency. So it's 10.1 kilometer per hour. And if you see the driver score, it is 94. Okay. And then the average speed, maximum speed, and the speed greater than 80 kilometer per hour, and the speed greater than 120 kilometer per hour. So it is 0 kilometers. But if you see here, acceleration, sudden acceleration, fast braking. And of course, while showing the demo, I asked the Kathy to accelerate suddenly and then put sudden brake suddenly. Okay. And then you can see that sudden turn and overspeed. So here there are 2 sudden turns. So based on that, the driver score is 94. So let's take, I am taking an the other history. You can see on 3rd September, okay, you can see that there was 11 harsh braking and then one sudden turn and overspeed, right? So one overspeed, right? That is 101 overspeeds. So based on that, the driver score is different. You can see the maximum speed. The maximum speed is 123 km/h. So for example, while teaching or taking class for data analytics and even statistics, so we will compute that value, maximum value in an array or minimum value in an array, and then we will give the task vector. With the same task, so we have taken from the real-time data, right? So here you can see 123 km/h. And also, you can see where the driver have applied a sudden brake and then they have applied a sudden turn. So I am taking the turn, right? See here. So here you can see the purple color. So here at these points, the brakes were applied suddenly. And then you can see that overspeed. You can see in this region, the vehicle is driving at overspeed, right? So based on that, we can see the driver score, right? So these things, so the students will be developing in that application, sir. So based on the data collected from the vehicle. And now here you can see what about the driver score? It is 97 because the sudden turn is only once and the maximum speed is 74. So if you see the tracking, right? You can see the tracking. The sudden turn is here. Actually, this is at Salem. Yes, at Salem. Anywhere, sir? You can see the location. The last week we met, right?
Yeah.
So this is from the history. So actually, last week I met Manibhadra sir. So at this place, right? So you can see that the history, and
Yes,
then
okay.
you can see that my driving history, right? And my score is only 72. So let's take another case, 897, 88. If you take that 88, you see sudden braking, sudden turn. 100. You can see 100. A good driver will have high score. A good driver will have high score, right? So here you can see 84 overspeed. Okay, fine. I will put a simple question here to all the participants. How to find the harsh braking and how to find the overspeed, acceleration, and all. So of course, I'm showing it is graphically, but if you see the data from the vehicle, okay, so how you find that it is an harsh braking? How you find it is an acceleration? Any one participants? Maybe you can reply in the chat box. We can unmute you. So I'm saying harsh braking. Surely you would have done this in another form, not in terms of automotive electronics. I mean, in terms of speed or other things, but surely you would have done this in the same in another form. You take this case. Okay, consider the region A to B. We consider the region A to B. What about the slope? You can reply in the chat box. You consider the region A to B. What about the
is
slope?
slope
Zero.
0.
Yes, fine. Thank you. And if we consider that A, and from A to 1, what are the slope? Slope.
Infinite or very high.
Infinite or it's infinite. That's all. It's
Infinite,
infinite.
yes.
Right? See here. Let's take here. Initially, the speed of the vehicle is 0. Okay. After some time, let's take. This is 60 km per hour. Okay. Let's take the blue color and the red color. Okay. So among that two, that is blue color and red color, which one have higher slope? Higher
Blue
slope.
Blue.
Yes, fine.
Blue.
Okay. Among the two, which one have higher acceleration?
Blue one.
Blue one. Fine. Okay. See here. Let's take this is B. Okay. So from O to A, O to B. Okay. We consider this region after B. What of the slope? After B, what of the slope? 0.
No.
Fine. So the slope varies only between 0 to B. That is for red color and blue color. Okay. So here, based on that, the sudden rise. Okay. Based on the sudden rise. So for example, now we can see the way. So here the slope is 0. If any obstacle comes, based on the distance, the driver have to take decision and then he have to slow down. Right. So suppose if we apply brake like this, and if we apply brake like this, see the difference? So what happened to the red color? Slowly increasing, but while applying brake, what happens? The sudden brake, right? The sudden transition from here to here. But whereas here, the smooth transition, right? So based on these slope values, the driver score will be computed, right? See here, this is the initial speed, okay, and this is the final speed. And based on how the driver accelerates, suppose if he accelerates suddenly, or if we apply brakes suddenly, what about the reactions of the passengers, right? So for example, if you're traveling the bus, if the driver applies brakes suddenly, so what about the passengers? The passengers will move forward. So if the driver applies brakes suddenly, suppose if he accelerates suddenly, what about the passengers? So they will go back, right? So here, so these data are collected from the onboard diagnostics board, okay, and then at the speed of the vehicle, and then the distance and the time. So based on that, so we have to compute the score. That is, by computing the slope, then we have to compute the slope, right? Okay. So here, acceleration is 0 and harsh braking is 0. So it says that the smooth transition from the initial speed to the maximum speed. And if you take the harsh braking, so there is a smooth transition from the maximum speed to the minimum speed. How will you identify the sudden turn in this case? So here you can see the harsh braking, totally 8 harsh brakings. So what does it say? The speed gets reduced quickly. Okay, the speed gets reduced quickly. So now we have to find out the current speed, and then the speed after some time, and then we have to find the difference, and then we have to find the slope. Basically, we have to find the slope, right? Now, how to find a sudden turn? And also one more thing I said about this case. What about that fuel tank level right now? 61%. And what about that fuel range? 340 kilometers. So based on the current level available fuel, okay, this vehicle can drive 340 kilometers. So let's take, of course, this question seems to be very simple, but it will be very interesting. It's like a school level question, but it will be very interesting to know the concept. Okay, so the kilometer is 340 kilometers. Okay, if the car gives an efficiency of 10 kilometers per liter, so what about the fuel level available? What about the fuel level available? It will be 34 liter. Okay, of course, this seems to be simple, but, and please make a note, this one, this mileage depends on the driver score. If he applies sudden brake, or if he accelerates many times, or if he do sudden turns, okay, so what about this mileage? The mileage get reduced. Okay, if the mileage get reduced, let's take if it goes for 6 kilometers per liter, okay, then what about the fuel level? It will be more. Suppose if the driver score is good and the automatically mileage will be more, okay, let's take 12 kilometers per liter. Now what about the fuel level? The fuel level will be lesser than the 34 liter. Okay, you can see here. See here, based on the driver score also, the fuel efficiency varies, right? So initially it is 10 kilometers per liter and the driver score is 94. Now you see here, okay. See here, the fuel efficiency, the total kilometer, the duration, the average speed, all these parameters put together. But if you see here, the overspeed is more, harsh braking is more, right? And now you see here, the driver score is 97, but the fuel level is efficiency is 8.5 kilometers per liter. But you see the duration and the total kilometer. Okay. I have the history. Now you see here, the fuel efficiency is very less, but the driver score is more. But why? Because the average speed and then the maximum speed and then the total kilometer runs. So we have to consider all the parameters, all are related, right? So this is about the connected cars data analytics, right? And see here, if we consider this, the latest generation cars, so that comes with AI enabled, But if you go and see the demo of Astar, MG Astar, they will disable this AI and then they will show the demo. But actually, that vehicle comes with AI enabled. But if you see that vehicle, they will disable that because that is not suitable in Indian roads. Even if you can take that vehicle on the highways, okay. So lane detection. So automatically it will detect the lane, and if you change the lane, automatically the vehicle will take the control, and then it will move to the lane. Maybe you can try with the test drive at highways where the traffic is very less or there is no traffic, right? And also it will detect the colors on the roads, right? So let's take, we have seen that on the roads, white color line, yellow color line, broken lines, right? So what about these functionalities, right? So we will see, and then we'll come back here. Yes. So what does broken yellow line says? And what about that continuous yellow line says? Anyone in the participants? What about the broken yellow lines? And please make a note. So hereafter, and if your car meets with the accident, and if all this A enabled which is installed in your vehicle, and if it have the data, okay. So based on this traffic signs and in road signs, so your insurance will be provided, right? So what about that broken yellow line says and solid yellow line says? Anyone? If you see broken white lines, what does it say?
The broken yellow lines means we can cross the road.
Cross the roads or cross that line?
Cross that line.
Line. Continuous line?
We shouldn't cross.
Double line?
Double line.
Answer is on the screen itself. Have anyone follow these roads? So we have discussed about the color detection while discussing about the traffic police, and then we have discussed about the traffic lights, right? So likewise here it have to detect the road that is black color, and then the lines on the roads, okay, whether it is white or yellow or continuous broken, right? So double line means is equivalent to a wall in between the roads, right? So everything, all the data will be trained to that this vehicle, right? That is the characteristics of the driver. A good driver will be trained in the form of coding, that is programming, so that this device have to take the decision like a human. After getting these data, this vehicle have to take the decision like a good driver. And so what about this left indicator and right indicator? If both are switched on, what does it say? Yes? Anyone? You can write in the chat box. When you will use this both indicators switch on. Of course, I said about the right and left previously, right? So at different locations, it have different meaning. Within the city, so it says that if you are using right, you are going to turn right. But on the highways, okay, so 4-track or 20-track lane highways, so there the information is different. So you will be traveling on one side, but you will be changing the lane from low speed lane to high speed lane or high speed lane to low speed lane. But if you use, okay, both on its emergency, Okay, fine. Exactly, both on its emergency and also used for parking. In the same way, if you use the right indicator at night time on the hills, what does it say? Please make a note, it have different meaning. The same indicator, either right or left, on the hills, night time it is different and daytime it will be different. Right? So all the things, all the traffic signs that have to be trained to this autonomous vehicle. That is very important. Actually, here a driver is communicating with another driver in the form of indicating lights. Okay, through indicating lights. So the same information will be shared between the vehicles in V2V mode, right? In V2V mode. Yes, participants, any queries? Any queries? Yes. Now I'll come to this question. We already discussed. Right. So the state diagram, consider a state diagram. Okay. So if we consider red color to green color, okay, it goes immediately. But whereas for going from green to red, okay, it will go with another state. Yeah. Why? And then why that 5 seconds? This 5 seconds everywhere. So here it will be mostly 5 seconds. So this time depends on the traffic intensity. Let's take A, B, and C. C will be mostly 5 seconds, not more than that. I have seen in many places in many traffic signs. So it will be 5 seconds. But A and B, that depends 60, 90, 30, whatever it is, that depends on the traffic density. But why it is only 5 seconds? First of all, I like to ask whether you understood the question. Say yes or no, or else I'll explain the question clearly. Okay. So mostly, how many of you handled a microcontroller laboratory, and then how many of you handled that traffic light system or traffic light experiment, either in 8085 or 8086 or 8051 or with the latest kits? How many of you handled traffic light controller experiments in your teaching career history? Handle, okay, fine. Any other steps? Sir, what is the difficulty you faced in teaching that experiment? whether the student could have got the output without any errors or at the first time. And what about the number of lines for the program? Maybe the other participants, you can share your experience. Yes.
With the exact getting timing is challenging based on the controller.
Timing is challenging, expensive. The same challenge the traffic light designers also facing. Yes, it may take time to explain that concept right now. And if any participants comes with innovative ideas or answers, then I can go with this. Otherwise, I'll go with the slides. But it will be very interesting if you handled the traffic light system. And now we have also developed a AI-based traffic light system. So completely, it detects the traffic signs through images, and then it controls the traffic. And if possible, in future, if time permits, maybe we can show the demo also later. Okay. So I will go with the slides. So see here, this one is the connected vehicle. So this is for two-wheelers, right? So this device comes with the connectivity. Okay. So as I already said that the M2M SIM will be enabled in this vehicle, and then it collects all the data like the Apple Watch, how it collects the human body parameters. Likewise, the health condition of the two-wheeler as well as four-wheelers. So that will be monitored by the service centers, even if you don't know that one. So they will monitor your health conditions. I mean that your car's health conditions, right? So you can see that the right statistics, the trip distance, the fuel level. So now it comes with the EV. So it's charging details, how much charge level is available on the vehicle. So in case of petrol engine, so it will be fuel level, and the total distance covered. Okay, and then the maximum speed, and then the location of the vehicle and other parameters. So likewise here, this is for cars. So this is for two-wheelers. Nowadays, if you take the two-wheelers, TVS or ATAL, so that comes with that connectivity, right? And then the same thing now with connected cars. Nowadays, most of the cars are connected cars. So you can see the right statistics, the maximum speed, car location, fuel range, and then you can control the tailgate, air conditioner, right? Fine. So this is a device to monitor the human health condition. Okay. So likewise, so this is to monitor the two-wheelers health condition or the four-wheelers health condition, and also it analyzes the rider's performance based on these parameters, how the driver drives the vehicle, right? And now that's all for the today's session. Now it's time for Q&A, question and answer session. So I lined up this right now. So what you have discussed, so we have discussed about the the data analytics, so the weather condition and the smart caps. Okay, so how the weather will be useful for selecting the caps, how this weather will be useful in selecting the food items. Okay, so and of course these things that will be available on the infotainment of your dashboard. Now, if you consider the latest vehicles, connected vehicles, if you want to search for the food availability, or if you want to search for hotels, whatever it is, so that will be available in the connected vehicles. Have anyone used this effectively, like Google, how it shows the nearby hotels and other things? Have anyone used this feature in your vehicle, whether it may be two-wheeler or four-wheeler? And then we have discussed about the smart phones and what will be smart. So the people's requirement that have to be satisfied, and only it is called as a smart, whether it is a classroom or a city or whatever it is, right? And then we have discussed about the smart cars, and then we have discussed about the price, a range of the different cars. So because of only the safety features, the price of the car is very high, right? So basically, the car is for transportation. And of course, nowadays all the cars comes with the luxury features, but the most expensive cars with the safety features, right? And then we have discussed about the connectivity. So how the connectivity takes place between the cloud and the application and the vehicle. And then we have discussed about the driver's characteristics, based on what parameters the driver characteristics is computed, right? And then we discussed about how these data are collected and how these drivers' characteristics are computed using the slope of the curves, right? Thank you, Manibhati sir, and thank you, GCE, for this wonderful opportunity. Now it's time for Q&A.
Participants can unmute and ask a questions. Let's put in the chat box. Sir, I have some query. Sir,
Yes,
if
sir, please.
from the car you are collecting the data, right, sir?
Yes, sir.
Sir, I mean, are you adding? Is the data readily available? Is anyone can access the data, or else we have to have our own what I can say sensors to access those? What method you are accessing?
It's actually,
Yes, sir.
we have connected one devices on the port. Okay, so that device will collect all the data. Okay, so from that device we collect the data through Bluetooth and then through cellular. So we collect the data and then we will move to the our cloud, and from there, so we export to the our application.
Okay.
So if you want to access actually we have planned for another demo, but in that case, staffs have to work on the system. So they can open the application and then they have to give that credentials. Once if they give the credentials, then you can also access the data, the raw data. You can access the raw data.
So the collecting sensors are all your developed one, right?
Yes, sir.
Okay, that's really great, sir, to see.
Thank you, sir.
You are doing a great job.
Actually, students, they will develop this app and then they will learn about actually what is the meaning of slope in different applications. So how, once if they come to know how to compute the driver score, actually we have developed this for driving school also. So during that learning phase, so this will suggest the drivers how to improve their driving skills. So based on the road signs and based on the data collected from the cars. So for example, if the road sign says 20 km/h, during the learning time, if the driver rides more than 20 km/h, then the driver's will be reduced. and then it will give a warning and suggestion to the learners that they have crossed speed limit. So there we use that AI model to detect the road signs.
Mm. Mm. Whether are you in collaboration with any government agency, sir?
Not
Because
with government agencies.
Ah.
So we have deployed in driving schools.
Oh, in Coimbatore.
Yes, sir. Coimbatore and
Okay.
Erode.
Hero. You're really useful for them actually.
Yes, yes.
Maybe the driver can, from his score, he can understand.
Yes.
Because most of the time they feel they drive well actually,
Yes, exactly.
but the number may reflect something different.
Yes, yes.
Ah.
Even if you think that take the driver, so if he applied brake, he comes to know that he is going to apply certain brake, but that will affect the passenger's comfortness.
Mm. Mm.
So a normal, as I already said, a normal driver will make all the conditions safe and make the passengers to sit comfortably in their seat.
Mm. Really a wonderful session, sir. Actually,
Thank you, sir.
so it's a Saturday weekend. I thoroughly enjoyed it, each and every minute of your session, and I hope the participants too, in spite of the weekend, it's a really good session to listen in the afternoon. Thank you very much, sir. I know you are busy, but still you accepted our invitation, and you got present for this session. Thank you very much, sir. Again, on behalf of GC Salem and our EC department, I thank you personally, sir. Thank you very much again.
I'd like to have some feedback from the participants.
Yes.
Maybe
yes,
one
yes.
or two questions.
Yes.
And then we will wrap
Yes.
up.
Yes, sir. Please. A
Please,
request of
participants.
participants. Yes. They can unmute themselves. I have enabled. They can unmute their mic and they can give their feedback.
Good evening, sir.
Yes, madam.
Meenakshi,
Good evening,
madam.
sir.
Meenakshi, madam. Yes.
Sir, it's a very wonderful session, sir. We always have some experiment which is going somewhere in the globe. But seeing in Erode lively, we have worked. It is very happy, sir, to see it. I'm so happy on seeing a live experiment, sir. And how it will be working during training time, sir.
Any time.
Yes, sir. Thank you so much, sir. Keep going like wonderful experiments, sir.
Thank you. Madam, in rainy timing, there we have to consider the propagation medium. So normally it will be air. Okay. But during the rainy time, the medium will be water, rainy water. So it is a very big challenge this automotive industry is facing to detect the signal in the rainy environment as well as in the ice environment.
Madam, one more thing.
Thank you.
Sir has his own R&D center in Coimbatore, right? So most of the students are going for internship, getting benefited. It would be really nice for the student community to be in touch with an industrial expert like Vimal sir. That's my request to all the participants. The real-time issues, and in IoT and embedded, he comes up with an very good pedagogy where he gives some case study and hands-on training. The student get, he kindles the curiosity and they get the work done. So
it's a wonderful thing, sir. Thank you, sir. Thank you.
We are lucky to have you among us, sir. Any more feedback from the participant? Someone has given the chat box. Yeah, madam only. Okay, sir. No feedback. Yes, sir. Thank you very much again, sir.
Thank you all. Thank you all.
Yeah, see you, sir. Bye, sir.